Now that we have a handle on the basic primitive data types that are available in JavaScript, we want to take a look at some of the more advanced ways we can store data. And the first of these is the generic type of an object. Now you may have run into objects in other programming languages. They're very prominent in high-level languages like Java and C++. You may have also learned about them previously in JavaScript. So I'm just going to go over a very brief overview here of how to use objects at a really basic level. We're not going to get into things like inheritance or polymorphism or all of these other more advanced object-oriented concepts, as that really belongs in another class. So to talk about objects most generically, first I just want to sort of orient you to what we mean when we say object in a programming language. Really, it's just a pairing of data and code. The data will be variables, sometimes called properties, and the code will be functions, or sometimes just generically referred to as behaviors or methods. In this little diagram over here, you can see the object sort of encapsulates methods here, which can be public or private, and then data, which should almost always be kept private. Now, the concept of things being public or private and having an interface is something that JavaScript doesn't really fully support, though it can be done with a little bit of trickery. So we're not really going to worry about that so much. All you have to really realize is that it has methods or functions and data, and they're all kept together in a single structure. Now in JavaScript, it achieves this by giving you something that is really just a collection of key value pairs. That means if you give it a name, which is a key, and you associate with that name some sort of value. And that's all objects are in JavaScript. Now there is a whole lot more underlying it that allows you to do things like inheritance and other stuff, but for the purposes of this class, we can think of them simply as just a collection of key value pairs. Let's talk a little bit more about that. Well, I do want to point out for anyone that is oriented in C++ or Java, this is it's sort of an object-like thing, but it's not strictly the kind of object you think of in C++ or Java. For those that care, the real precise difference here is that the objects we work with in these higher level languages are what we would call class-based objects, and you probably know what a class is if you've worked with those. And then the objects that we use in JavaScript are going to be what are called prototype-based objects. And that makes for a very different sort of system. It can still achieve the same things, but you're going to find that it's very structured in a very different way. Just be aware of that. So let's get a little bit more into what we mean by keys and values. So as I said before, you give it a key, and a key itself is just sort of a name that you can use to associate with this value. It's not all that unlike a variable name, but it is inside of an object, so it really isn't a variable by itself. Typically they are strings, and it can really be any string that you want. There's also something called a symbol that you can use to assign these, but we aren't going to get into that. And I always recommend that you should probably follow the variable name standards, meaning that it should always start with a letter, and that you can only use upper or lowercase letters, numbers, and underscores. Now, you can actually use any string you want for a key in JavaScript, but it gets a little bit harder to work with them if they aren't standard variable names. So unless you have a really good reason, I recommend naming them the same way you would name a variable. Values, on the other hand, can be any primitive values: bools, numbers, strings, and the others we talked about, null and undefined, and nan, and all these other types of values that are available. Those can be the values associated with the keys. You can also associate objects or arrays, which we'll be talking about shortly. And lastly, you can associate a function with a key. And that's the key thing. So we talked before about how an object is a pairing of both data and functions or methods. This is how JavaScript achieves that. The values that we're associating with these keys can be standard data, which is booleans, numbers, strings, that sort of thing, or it could also be a function. And if it's a function, well, then that's the other half of what an object needs to be. Let's see a little bit of an example here. This is just something that I whipped up just to give you an idea of what this looks like. So here you see we're declaring a variable named foo, and we're setting it equal to this curly brace block. This is how we declare objects. I showed this before in the previous example when we were talking about data types. Curly brace blocks always denote an object when you set them equal to something. Inside this, we're going to have key, colon, value. And all of these are key, colon, value And then eventually we even have a function here that does this. All the key value pairs are separated by commas. You'll notice this here. We don't have one after the last one, though, because it's not necessary. Then we show us working with this a little bit, actually printing out this information. Let's go ahead and jump over into Atom and actually write this and see what we can do with it. So, as before here, I've already set up a basic project that's based on our local server system and filled in the basic data here for the page. And I'm linking in index.js, which is sitting in the public folder. Go ahead and save this. Now, over here in index.js, let's create an object. I'm going to create essentially that same one that we had just created. I'm going to call it var foo equals, and then give myself some curly braces. The purpose here now is to fill this in with key value pairs. So we have bar is 10, greeting is hello, so let's do those. Bar is 10, greeting is hello, just in single quotes. And this is just an example of two values we've now put in it, and these are usually called properties. So a property of foo is bar, and its value is 10. A property of foo is greeting, and its value is hello. Let's go ahead and put in this last one, which is a function. We're going to call it math, and it's basically going to do some math. I'm going to give this a space here. Math. And here's where things feel a little bit weird. You're going to put the name first. We don't put any parameter list on it or anything like that. We just then start typing what would normally be an anonymous inline function, like you've seen before. So we say function a comma b, and then we give it a body. And now all we have to do is write the body of the function right here. In our case, we're going to return a plus b. For now, let's leave it as that. So there we are. It has three things now. Foo has a property bar, which has the value 10, a property greeting, which has the value hello, and then a function math that will add two numbers together. Let's go ahead and do this and see what we get. So console dot, I'm going to do .info. It's the same as console.log. It just doesn't throw a warning when you use it. And let's first just put foo right out to the console. So we'll save this, and then let's go take a look at that console. Bring up the console exclusively here. All right, and you'll see it dumped out an object. And then I can expand this, and you can see all of its different properties. It has bar, which is 10, greeting, hello, and then our function math, which technically is also an object and has all kinds of other things going on. But for our purposes, what we see inside of it isn't all that useful. Now, for those who are really interested in the details of this, as I mentioned before, objects in JavaScript are prototype-based. And that means that they are always copied from some canonical prototype object. In our case, that is sitting right here. That would be the actual object, capital O object. And that provides it all of these different functions. These functions are inherited from its prototype. Every object, if you don't specify some other prototype, uses the capital O object as its prototype. If it uses some other object as its prototype, then that object will also have a prototype, and there will be what we would call a prototype chain, which is a lot like a parent-child inheritance chain. None of that is stuff you really need to worry about, but for those who are trying to build a parallel between what we use in high-level languages and how JavaScript works, this is where it's all buried, under this proto-object. You should never really mess with that directly. There's lots of other ways to work with it. Let's keep going here. Let's print out console. Let's say I want to print out the bar member of foo. Well, I would say foo dot, which means I want to access one of its properties, bar. So this is going to take the object foo, and it's going to print out bar. I can also do this with foo dot greeting. Here we are. So we're still printing out the object up here with its properties, but now the other two are printing out first the value 10, which is the value of foo.bar, and then the value hello, which is the value of foo.greeting. We can access all the different properties that belong to foo this way. We can also do, again, we'll print this to there. Actually, let's do this by itself first. Let's run that function math. Let's see, var answer equals foo.math, and then give it a couple numbers, 2 and 2, right? 2 plus 2. You know what the answer is. The answer is answer. Right like that. And there we are. The answer is 4. So here, I called a function that was part of foo. Generally, this function is still written the same way any other function is. It's just in order to call it now, I don't just use its name. I use foo.itsname, foo.math, because it's part of foo. Now, why would I want to do this with my functions? What's the benefit to being able to couple data and functions together? Well, it's because that data can then be associated with it in a strong way. For example, I can come in here, and instead of just doing a plus b, I can take a plus b divided by bar up here. And again, if you've done some object-oriented programming before, you've seen this. This basically says, use the variable bar that either is a global variable or is a variable that's in the scope of foo. Now, JavaScript has one distinction here. You'll notice if we go over this, it says bar is not defined. Well, it is defined right up here, but it's not a typical variable. It doesn't have block scope. It doesn't have global scope. It's actually a property of the object foo. When I'm inside a function that's part of an object, I can access its properties by saying this dot whatever. This should feel real familiar if you've worked with Java or C++. This basically says, take the object I'm currently inside of and use its property bar. Now, in order for this to be interesting, we kind of need to make more than one. Now, we could do that. That gets a little more complicated, but for now, let's just go ahead and see what happens. So now when I do foo.math 2, 2, it's going to add them together and then divide by this dot bar. The answer here is no longer quite so obvious, but you got to be able to do it in your head. Think it through, and then let's save it and see what the real answer is. Not too hard. Just the original answer 4 now divided by foo.bar, which is 10. So, this is the basic idea behind objects. Note, when there's a prototype approach, there is no class, there is no blueprint that says all objects of this type are going to follow this pattern. It's kind of just up to the programmer to keep that pattern consistent and to make sure that all objects provide the particular properties and functions that you need. This gets right back to that idea of duck typing. You make it do what it needs to do, and it doesn't really matter what its type is. It's an object, it has properties. As long as it has the properties you need to work with, we don't care how it got them or what those properties really mean. Those properties simply need to be there. And when I say properties, I'm including functions in that as well. Let's take a look now at how we can make multiple copies of the same object. Now, this is not something we're probably going to do in this class, but it's really hard to do anything useful with these things if we don't at least support this. To do this, we're going to talk about what a constructor is. And the constructor, if you've done that before, is part of the sort of properties of an object. It's a special function that every object has that it uses to initialize itself and to assign values to everything in that object. And in JavaScript, it's going to pretty much work that way too. It will be a function that's used to make an object, not surprisingly, and it will allow you to assign values to the this variable, just like we did when we accessed this dot bar. Those particular values will then be returned as a brand new object that fits that pattern. You need to call it using the new keyword. Again, if you've done C++ or Java, you'll have seen the new keyword before. Now, it's sort of just a handy shortcut here. It doesn't quite work the way it does in those languages, but you'll see it is very much along the lines of what new does in those languages. Now, again, I've mentioned this in talking already, but I just want to have it in the slides officially. Inheritance is done through something called a prototype chain. What I really want to say is it's complicated and it's very different from how classes work. It's outside the scope of this class. So if you want to get deeper into it, you can go ahead and take a look at how prototype chains work in JavaScript. Let's see the syntax for a constructor. You basically declare a function and give it a name. And we typically want that function to have a capital letter as its first letter. The reason for that is that that sort of tells us it's going to create an object. Object names have capital letters in them. It can take parameters, and it usually would want to because it's going to use those parameters to assign values. It then goes through, and as I said, it's going to assign values to quote-unquote this. this.bar equals x, this.greeting equals hello, and then this.math equals function. It's going to look a lot like what we did before, only you don't have the key or property value kind of arrangement here, key value. Instead, we're just assigning everything to this. Then, to actually make one, I declare a variable and set it equal to new and then the constructor. That allows me to construct one. Let's go ahead and do that. Let's convert our little foo here into a proper constructor that we could call multiple times. So it's a function, and since it's going to construct an object, I'm now going to name it with a capital F, and we're going to let it take a single parameter, x. It then needs a body, and it's basically going to say this.bar, instead of equals 10, we're now going to set it equal to x. And so that means we can customize it. Every foo we can create can have a different value for bar. Then let's say this.greeting equals hello. We don't do the key value pairing anymore. And then here we're going to do this.math equals the function. And then I do need a semicolon right here to end that off. And finally, we need a semicolon, or we don't need a semicolon at the end of this because that's just closing out the function block itself. Now the only complaint that's left here now is that we have defined it but never used it. Let's go ahead and do that. I'm going to come down here and say var foo, or we'll call it my foo, equals new capital FOO, that function up there, and we'll pass it the value 10. Now down here, let's put in my foo everywhere we had foo before. We should get the exact same results. Notice here, though, it tells me, instead of calling it an object, it now says this is a foo. And therefore, my foo is a foo like that. We can look through it here. You can see it has bar of 10, greeting, hello, and that same math function. The prototype object was just the constructor foo. That's all that was in the prototype object for this one. And then underneath that is the capital O object prototype still in there. So here we start to see a prototype chain happening. Which again is a little complicated. I'm not expecting you guys to really worry about that. Let's see, why would we want to take this constructor approach as opposed to taking the just writing it right out, defining it directly? Well, of course it's because I can make more than one of them then. I can say my foo2 equals new foo, and let's say this one has a value of 100. Now I can print out all these values for foo, but then also for my foo2. I don't want to redeclare answer here. We'll just reuse it. And then go through 2, 2, 2, 2, and then we got our answer. And here we go. So for the first one, 10, hello, the answer is 0.4. The second one is 100, hello, and the answer is 0.04 because we're dividing by 100 now. These are the basics of working with objects in JavaScript. I do also want to preface all of this by saying there is a brand new interface to working with objects available in the latest version of ECMA script. I've mentioned before ECMA 2015. That particular version is much more like the class objects that you're used to. Now it doesn't actually change the underlying representation. It's what they call syntactic sugar, which just means it allows you to type it in using words like class and things like extend, which you might be familiar from in Java. But it just, when it goes to run it, rearranges all of those into the traditional prototype syntax that always works with Java. That sort of syntax is not available in the browser. It has not been implemented by all browsers yet. And so in order to work with it, you have to do something called transpiling, where you compile from a later version of JavaScript down to a version that works in the browser. This is stuff that's well beyond standard web programming. But there are tools out there that are very good at doing this. Namely, one is called Babel, which seems to be the de facto standard for transpiling. And it can allow you to use that syntax now that you may be more comfortable with. All of this is beyond the scope of this class. For now, all you simply need to know is that objects are really just key value pairs. Those values can be functions. And be familiar with this syntax that we use in order to declare a constructor and to access all the properties that are present in the object.